A perfect day to sit inside and do mathematics. Alright, here's the unit circle again. There's a red point sitting there at coordinate 1, 0, ready to take its journey around the circumference of the circle. So there it goes. While it's going, you can see the angles appearing. Angles denoting where the point is at that moment. Positive direction is counterclockwise, negative direction is clockwise. The distance from the origin towards the circle circumference is the radius, and you can see it right here. And because it's a unit circle, it always has a distance or a length of 1. And the diameter is the full width of the circle. Here's the point again, sitting at the starting position and starts its journey and stops right here. It's still in the first quadrant between the angles of 0 and 90 degrees. As usual, we draw a line from the origin towards point P, and this line makes an angle with the x-axis. Let's call it again alpha. In order to find the coordinates of P, we look at its components again. First the xp and the yp. The xp can be calculated by taking the cosine of this angle alpha. And for that you just use your calculator, as we'll see in the examples later in this video. And the yp, you take the sine of the angle alpha. Before we start calculating, let's look at a couple of very easy examples. So here's the point at the x-axis, and it has an alpha, an angle with the x-axis of 0 because it's on the x-axis. So now, what would be the x-coordinate of this point? You can see it directly in the graph. It is actually 1.0. So the x-coordinate is 1 and the y-coordinate is 0. Therefore, you can say that the cosinus of 0 degrees is 1 and the sine of 0 degrees is 0. And the overall coordinate is 1.0, 1,0. It's easy, huh? It's actually so easy that I'm just going to click through the next couple of slides and let you just look at it and see if you can follow what happens. And we're back at the starting position. So alpha 360 is exactly the same as alpha of 0. Finally, time for an exercise. Here it is. So we have the angle alpha is 65 degrees. Calculate coordinates of point Q in 2 decimals. Alright, let's start where we always start, by checking the components, the x and the y component of point Q. The x component can be calculated by taking the cosine of alpha, and the y component can be calculated by taking the sine of alpha. This time we actually have a number that we can substitute for the alpha, which is 65. So from this point onwards we need to use our calculator. Here's mine. It says wissenschaftlich, that's the German word for scientific. You need this setting for your calculator because we need to be able to use the trigonometry functions right there. But first, before we're going to enter something, be sure that your calculator is set for DEG. It stands for degrees. So we have 3 settings here. We have DEG for degrees, we have RAD for radians, and we have GRAD, sometimes GR or maybe sometimes even just G, for grads. So at this moment we don't need rad or grad, so it needs to be on degrees because what we're inserting for the alpha are actually degrees. So let's insert this, and the answer is 0.4226 and so on and so on. But the question was to calculate the coordinates of point Q in 2 decimals. Therefore 0.42 is the answer for the x coordinate of point Q. Now the y coordinate, similarly, we type in the 65 degrees and take the sine of it, and we end up with 0.9063, which is 0.91. So now the coordinate of point Q is 0.42, 0.91. In order to be sure that we didn't miscalculate anything here, we're going to have a look back in the unit circle and we have a look at the Q. So the xq is somewhere halfway between the origin and 1 on the x-axis. So it's somewhere around half visually. So now that's correct. If you have a look at this number, 0.42, that is probably correct if you look at this picture right here. Similarly, for the yq, it's almost 1 on the y-axis. So the answer was 0.91, probably also correct. Very important to always check visually if your answers make sense. If you, for instance, have an answer y coordinate is 17, then you're very likely have made a miscalculation. Here's the second example. So in this example, the alpha, the angle, is 209.3 degrees, which puts us well in the third quadrant. Calculate the coordinates of point Z in 3 decimals. Okay, so now we again start by breaking this down in their components. The x of Z somewhere around -1, a little bit before -1. Y of Z somewhere halfway between the origin and -1 on the y-axis. Okay, xz, cosinus of this angle, yz, the sine of this angle. We start filling it out. Xz is minus 0.87 and so on. This is probably correct because looking at the unit circle, you can see that it's very close to -1, which is consistent with this number. In 3 decimals, that would be minus 0.872. The same for yz, sine of 209.3 degrees, which is minus 0.489 and so on. In 3 decimals, 0.489. The answer to this question, the coordinates of point Z, would then be written as minus 0.872, comma, minus 0.489. Thanks for watching. Next time we'll introduce pi, and that's not a piece of cake, it's a number.